Okay, more problems about minimum and maximum values. So this part of the question, some part of it, you shouldn't get it wrong. That is because, again, in order to determine minimum or maximum, you just take your function and then you find f prime of x or whatever. If this t of x, t prime of x, and then you equate it to 0, then you solve for x or for whatever variable is there. Then after that, you take the answer that you get, you substitute into the original to get the minimum or maximum. For any context, let's look at the examples below. A, determine the maximum value of f of x. Again, look at it. Just I have to find f prime of x, equate it to 0. So you just, first step, find f prime of x, or the derivative of f, and then equate it to 0, then solve for x. You get that x is 2. Then you take this 2, you put it into the original. That is, where you see x, you're going to put 2, 2 there. That is 2, 2 there. Then that means the maximum value is 14. Now you'll notice that they can't ask both minimum and maximum. It's either minimum or it's maximum. The way you approach it, the same every single time. So for B, determine the value of minimum value of, you see sometimes they say minimum, but then the way we approach it, the same. So A and that, so you just have to find the first derivative. To find the first derivative, remember we have to change it first. Remember you have to take this x to the top first, that is going to be -1 there. So before we start, it's going to look like that, because we know we can't find the derivative when it's a fraction. Now we find the derivative. Since it's a, not f of x, you're going to use this notation. You're still finding the derivative. So dA over dx is going to be, here there was a 1, so it dropped, -1 going to be only 1 here, x exponent 0. 16 minus 1 times positive 16 gives you -16, then -1 gives you -2, and then this one is 0. And then from there you equate this to 0, take that equal to 0, and then you algebra solve for x. That is, you can bring this side, put the x squared at the bottom, then multiply by x squared on both sides. Multiply by x squared on both sides. Then you have that, then apply square root, not forgetting plus minus. Now the question said, if you check the question here, they said x is bigger than 0. That means the answer that you get, you have to take the positive one. And then after taking the positive one, you have to go to the original, substitute 4 where you see x, and then get the minimum value. Next example. So we often have to determine an expression for a quantity that has to be maximized or minimized. Same context. Well, a different context, but then same way of getting the answer. So determine the maximum area of a rectangle with a perimeter of 100 meters. So the focus is area. After finding the area, you find the derivative of that area. Anyway, so in this case, they said the perimeter, they gave you the sketch. So you just need to remember what area is, what perimeter is in terms of a rectangle. So perimeter, it means when you add all the sides, you get 100. So if you say x plus y plus y, you're going to get 100. That's perimeter. So if you simplify, it's going to give you 2x, 2y equals 100. Divide by 2 on both sides, get that x plus y equals to 50. Then make y sub the formula, you get that y is 50 minus x. So here you can write 50 minus x, 50 minus x. So you can remove the y's and have the same variable everywhere. That means now, if you want to find the area, remember area is length times breadth, or this side times this side. Now, when you're going to find the area, remember the question said the area, not the perimeter. So the perimeter was only helping us to find the other variable. So with area will be x times y. So this side times this side. But then we know y is 50 minus x. So x times y, but then the y is 50 minus x. So multiplying, you get that the area is that. Now, if you can get that, now to find the maximum, just find the first derivative of that and equate it to 0. So as you can see, first derivative, the first derivative of that, and then equate it to 0. So as you can see, first derivative, and then solve for x, you get 25. Take the 25, put it into the original area equation there. Then you get the maximum. Another example, a box with a square base is to be made to contain a volume of 108 centimeter cube. The box must be open at the top. So it's open here. It's open here. You can see inside. Anyway, let the base length be x, so there's the x, and then the height be h, as shown in the sketch alongside. Show that the total outer surface area of the box is given by, that is, if you find areas of all the shapes that makes the outside of this box, you'll get that. Now you just need to know how to find the area of rectangles and a square. And then so you have this one appears 4 times 1, 2, then there's this side which is outside, and this one, so it's 4 times that. So area of that is this times that, so x times h, 4 times. And then we have the base, this one that's on the floor, so that one will be x times x, so that's x squared. So the surface area will basically be 4xh plus x squared. That is the surface area. Now this is surface area. Now with this one, if you look at the what they said you should find, this doesn't have an h, so here we have an h. You see this, we need to remove that for us to end up there. Now to remove it, you're going to use this volume that they gave us. So it said the volume is 108 centimeter cube. Now you need to understand how to find the volume of this thing. So the volume will be the area of the base times height, just like how we did it in grade 11. So you need to remember that. So it's going to be x times h. So x squared times h, that's the volume. Now they told us the volume, so x squared times h should be equals to 108. And then you make h sub the formula, as you can see here, and you're going to take that h and substitute it where we see h there. That is the equation we got here. And then you're going to end up with what they want. So you need to remember how to find volumes, areas of different shapes. But look at this one. Even if you couldn't find it for A, you can still do things like B and C. For B and C, you just need to find the minimum. And the minimum is you take the equation, then you find the first derivative, equate it to 0. Look at it. To find the derivative, you take this x to the top, it becomes that. Then you find the first derivative, and then you equate it to 0. Then you solve for x. Then you put it back into the original, then you get the answer. So you can still get the answer. C, determine the minimum. That is, again, taking this, basically what they teach us, taking this, putting it into the original area formula. No, the length, sorry, yes, the answer you get there, the length, base length, outer surface area, yes. Remember the surface area is given by that. Now, here they wanted the dimensions. So they just wanted the x, and then you find the y, and so on. So after finding the x, now you can find the height as well. Remember you said through this formula, you can find the height as well, and so on. So, but then you just needed the x. Got the x as 6, and you just put it there. And then we found the surface area. I wanted to stop there because of the noise. But anyway, let me just do the last one. You'll do the other ones for yourself. You just need to find the volumes and all that. So the sketch challenge side, so graph is that, f of x is given by that, g of x is given by that, pq, the line segment, parallel to that, determine the maximum length of pq. This also can be asked in functions. So to find this length, you just need to take this equation minus this equation. Always, you just need to know that. So that is to find the length, top minus bottom. Top equation minus bottom equation. You just do that, and you're gonna get the length of PQ. To find maximum, find first derivative, equate it to 0, get the x's, take the positive one because it's on the right hand side, on the positive side, and then substitute it in this equation. Then you're gonna get the maximum. I'll stop there. Oh, sorry about the